Hi guys, today is April 15th and we're going to be drawing angles with and reference angles. That's what we're going to be talking about today. Okay, and so the very first thing I want to get into is what's this angle that's drawn in what's called standard position. Okay, all right, so a couple things we want to add to this. Okay, so one is the initial side, okay, is on the positive x-axis. Okay, so that's one of the sides, and we're always going to start on the positive x-axis. So initial side is on the positive x-axis. And this is, you can think of this as kind of being like a clock, okay? All right, so right here, okay, this angle, this side right here is our initial side, okay? And then we're going to rotate around like a clock. Okay, we're going to rotate around, and this is going to be our angle that we rotate, and we're going to label that theta. Okay, all right. And so this is our vertex, and the vertex of the angle is at the origin. Okay, so that's the second part of standard position. Okay, vertex of the angle is always at the origin. Okay, so is at the origin. Okay, so right here, this point right here, that's the vertex, and it has to be at the origin. This is the initial side. That's the name of it. Okay, and then this is the other side right here of our angle right here, right? And there's a name for this one too, okay? And this right here is called the terminal side. Okay, so there's a little bit of vocabulary we have to understand. Okay, initial side, terminal side, vertex. So it's I always like to stand up in front of you guys and I rotate my hands around, and I like to show you guys like, okay, we're rotating around and around and around. And unfortunately, I can't do that anymore, okay, because of this distance learning thing. All right, so the initial side's right here. Okay, we always start our angles on the positive x-axis, and then we rotate around like we would a clock. Okay, so this is counterclockwise, right? We're going against the direction of what a clock normally goes. Clock normally goes this way, right? Around. Okay, so we're going counterclockwise. All right. Okay, so that's that. Let's go to the next thing, and we're going to talk about there's two different ways to measure angles. Okay. Okay, so the very first thing is, okay, when we can measure angles two different ways, one with positive angles and one with negative angles. Okay, so there's the sign of your angle tells you the direction in which you rotate. Okay, so if we're rotating counterclockwise, like in this, remember this is the initial side and this would be the terminal side. This is my angle theta that I'm rotating, right? And that's a counterclockwise rotation. Okay, counterclockwise rotation. Then that's considered a positive angle. That's what we define a positive angle to be. All right. Again, this is the initial side and this is the terminal side. Okay. Here we have the same diagram, but we're going to rotate clockwise. So we're going to start with our initial side right here on the positive x-axis, vertex at the origin, and we're going to rotate around clockwise until we reach this terminal side here. Now, this angle that we rotate is still angle theta. Now, it's a different theta than this one, but it's still called angle theta, the angle we rotate, okay? And this would be the initial side, and this would be the terminal side. This is where we stop the angle at, okay? And we've rotated clockwise this time, right? So this is a clockwise rotation. And when we rotate clockwise, that's a negative angle. So this would be like if we rotate, let's do a real simple one, okay? If we rotate from here, this initial side to this angle right here, this angle right here is a 90-degree angle, right? So we would have rotated negative 90 degrees. If we rotated all the way to the negative x-axis, starting on the positive x-axis, and we rotate over here, that'd be negative 180 degrees, okay? Now over here on this one, if we rotate to right here, that would be positive 90 degrees. If we continue on, then this would be positive 180 degrees. And you could keep going, okay? So this would be positive 90, positive 180, positive 270, positive 360. And you could actually keep going around and around and around, okay? So over here, if we rotate this way, okay, this would be negative 90 degrees, negative 180 degrees, negative 270 degrees, negative 360 degrees, and we could keep going around more than 360 degrees. So in trigonometry, we can have positive angles and we can have negative angles, and we can have angles of any size, okay? So we can have angles that you could have an angle that's 5,360 degrees, okay? So you could have a lot of different sized angles. In geometry, you're usually you're limited to 180 degrees, okay? Because those are the angles, the sum of the angles of a triangle. But actually, in reality, you can have angles bigger than 180 degrees, okay? All right, so we want to move on to the next thing, okay, which is called coterminal angles. Okay, so for coterminal angles, what a coterminal angle are angles with the same initial side and terminal side, okay? So that's the definition of it, okay? So angles with the same initial side and terminal side. Okay, so over here in this diagram, I did this specifically. This is an exactly a 45-degree angle, okay? So from the positive x-axis rotating positive, this angle right here is 45 degrees, okay? Now, let's find another coterminal angle with that, okay? So let's have an angle of 45 degrees, okay? Now, what's another angle that would be coterminal with 45 degrees? Okay, so we rotate 45 degrees. If I do one more full rotation all the way around, that'd be adding 360 degrees to this, right? Because one full rotation is 360 degrees. So I could get another coterminal angle by taking 45 and adding 360 degrees to it. Okay, so a coterminal angle with 45 degrees would be a 405-degree angle. Now you may be wondering, like, Mr. Mitchell, how'd you come up with that? All right, well, we came up with this by taking the 45 degrees, this one previous one, and adding 360 degrees. Okay, so how can you get a third terminal one, coterminal one, right? You could take the 405 degrees and add another rotation, right? So we go around, we go to 45 degrees, we go around 360 degrees, now we're at 405 degrees. We can continue going and rotating around in the positive direction, which is counterclockwise, and back to this one. So we could take the 405-degree angle, add another 360 degrees to it, and we'd have a third coterminal angle, okay? So if we add 360 degrees to 405 degrees, that'd be 765 degrees. Okay, and how did I get that? Well, I got the 765 degrees by taking the 405 degrees and adding another 360 degrees. So I could just continue on doing this, right? Okay. All right. How about we can, so those are coterminal angles that are all positive. Could you have coterminal angles that are negative? And the answer is yes. Okay. So if we start right here, okay, and we rotate with a negative rotation, right? With counter, we're rotating clockwise, and that would be a negative angle. And we start right here on the initial side. I could start right here and go all the way to here. Now, what would that angle be? Now, because we're rotating clockwise, I know that's going to be a negative angle. All right. Now, let's talk. What if I went all the way around and made one full rotation? That'd be negative 360 degrees. Now, I haven't rotated that far, right? Because there's this empty space right here, right? I haven't rotated all the way to here. Okay, so how much have I rotated? Well, if we back off the 45 degrees, we have rotated negative 315 degrees. Now, how could I get that negative 315 degrees? Well, I could have taken this 45 degrees, and instead of adding 360 degrees, I could have subtracted 360 degrees. Okay, so that would start to give me some negative coterminal angles. Okay, so we could have negative 315 degrees. Okay, all right. So how did I come up with that one? Right. Okay, so how I came up with this one is I took the 45 degrees, right, the initial one that we started with, and I subtracted 360 degrees, okay? Now, could I keep rotating in that direction? Yeah. Now I could take the negative 315 degrees and subtract 360 degrees, and that would give me negative 675 degrees. Okay, now, how did I get that negative 675 degrees? I got that by taking the negative 315 degrees and subtracting 360 degrees, because 360 degrees is a full rotation. Whether it's adding it or subtracting it, you're doing a full rotation back to that coterminal or back to that terminal side, okay? Okay, so we could keep doing this, right? We could do another one, right? We could take negative 675 degrees and subtract 360 degrees, and we'd have another coterminal angle. So you could just continue doing this, okay? So one way to get coterminal angles is you take your theta, right? And you can either, and that's your starting angle, okay? You could either add or you could subtract 360 degrees, because you'd be back to where you started if you rotate a full 360 degrees. So you start with the angle you're at, and then you add 360 or subtract 360 degrees, and that would give you coterminal angles. Okay? So that's what coterminal angles is all about. Before we go to our next page of our notes, what I want you to do is pull this diagram. Let me zoom out a little bit. Okay, so it looks like this. Pull this, and it's double-sided for you guys, and it looks something like this, okay? Pull that out of your packet, all right? So go ahead and pause the video right now and go look for that in your packet, okay? All right, so what I need to do is I'm going to give you angles that are in radians, not degrees, because we're going to really transition into doing all of our angles in radians. Okay, so what I have to do, it's actually radians. Once you get the hang of it, it's going to be easier than degrees because it's smaller numbers. Okay, what I have to do is teach you how to count by different values. Okay, so the very first thing I want to teach you is how do we count by pi? What's the rotations for pi? Okay, if we're just rotating by pi, so counting, let's label this first one counting by pi. Okay, so we know from yesterday, okay, that this is angle 0, okay? So it's 0, or we could even consider it 0 pi, okay? So we don't usually say 0 pi, we just say 0, okay? So this is angle 0, okay? Now, if we rotate from what we just learned, if we rotate counterclockwise, we rotate this way, right? All right, and we go all the way to over here, to this point right here, all right, initial side and the terminal side is right here, then that would be angle pi. Because remember from yesterday, pi and 180 degrees are the same thing. So this would be pi, okay? If we keep going all the way to right here, back to where we started, that would be 2 pi, okay? So I'm going to put comma, 2 pi. All right, keep going. Now we're back to here. That would be 3 pi. I'm going to put the comma over here, 3 pi. 3 pi. Okay, keep going. This would be 4 pi. And this would be 5 pi. Keep going. This would be 6 pi. And so we're starting here and we're ending here or here, right? On this side right here, okay? I wish I could say, do you guys get that? Do you understand? Okay, so starting right here with our initial side right here, and we rotate all the way to here, that'd be pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. We could keep going, 7 pi, 8 pi, 9 pi, 10 pi, and we could keep doing that, okay? So you notice all the odd pi's are on this side and all the even pi's are over here, right? Okay, so where is the angle 12 pi? Well, because it's 12 pi is even, right? We'd start right here on the initial side and we end up right at the same spot, right? We'd end up on this side, okay? Okay, now that's with positive angles. We could also do this with negative angles, and we would just be rotating, starting here on the positive x-axis, we would be rotating clockwise, right? And if we count by pi's and we go this way, this would also be negative pi, okay? So we can write negative pi. All of these would land, would be coterminal angles, okay? So negative pi, so we're rotating this way with a negative angle, negative pi, this would be negative 2 pi, so comma, negative 2 pi. Then we keep rotating in the negative direction, okay? So clockwise, then this would be negative 3 pi. Keep going, this would be negative 4 pi. And then negative 5 pi. Keep going, this would be negative 6 pi. And once again, all the even pi's are right here, okay? So 2 pi, 4 pi, 6 pi, 7 pi, or not 7 pi, negative 2 pi, negative 4 pi, negative 6 pi, negative 8 pi would be over here, okay? All right, because we're gonna need to draw these angles, okay? Like where is, let's do it in degrees, where is the angle 150 degrees, okay? So we're gonna need to be able to do this in radians too, okay? All right, so now what I wanted to do is go to the next diagram, okay? And I want to count by pi over 2. And the more of these you do, you'll go, oh, I'm starting to get it, okay? Counting by pi over 2. Now, you can also think of this as being half of pi, okay? So we know right here, from here to here is pi. So where's pi divided by 2? Well, it would be right here, okay? So this is still, we start at angle 0 pi or 0, okay? And this would be pi over 2, okay? Now this is pi, but I'm counting by pi over 2, so this would actually be 2 pi over 2. Keep going. This would be 3 pi over 2. Keep going. We know this is 2 pi, or another version of 2 pi is 4 pi over 2. Okay, we're counting by fractions, okay? So then we can keep going, all right? All right, and we're gonna be back up here. So this is pi over 2, 2 pi over 2. Now you're never gonna see 2 pi over 2 because somebody would reduce that. It would become pi, right? Okay, you're gonna see 3 pi over 2, okay? You're not gonna see 4 pi over 2 because somebody would say, call that 2 pi because that reduces to 2 pi. Okay, let me put a little comma right here. Okay, so we could keep going. This would be 5 pi over 2, 6 pi over, no, not 6 pi over 2, sorry. 4 pi, let me back up. Okay, so 0 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. Right here would be 6 pi over 2, okay? But what is 6 pi over 2? It's really 3 pi, right? Because that reduces, okay? This would be 7 pi over 2. This would be 8 pi over 2. This would be 9 pi over 2. This would be 10 pi over 2. Another one for this one would be 11 pi over 2. And we could keep doing this, right? We could keep rotating around and around. Every quarter turn is a pi over 2, basically, okay? So pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2, 8 pi over 2, 9 pi over 2, 10 pi over 2, 11 pi over 2, 12 pi over 2. What's 12 pi over 2? That's 6 pi, right? 12 pi over 2, which is an even pi. So it's going to end up right here, okay? And you could just keep doing this over and around and around. You could keep going around and around and around and around, okay? All right, so we took from 0 to pi and we broke it into 2 pieces because we're dividing by 2, right? So that would make this one pi over 2, this vertical, it'd be the positive y-axis, right? Okay. All right, so that's counting by pi over 2. Except I didn't talk about this. We could rotate with a negative angle, right? So we could go, if we're going this way, that would be the positive angle, right? If we rotate this way, that would be a negative angle, okay? So if we start here and start going this way, and this is 0, then this would be negative pi over 2. So 3 pi over 2 and negative pi over 2 are coterminal angles because they start and stop at the same spot, okay? So comma negative pi over 2. Then this would be negative 2 pi over 2. Now, you're never going to see negative 2 pi over 2. What you would see is negative pi, okay? This would be negative 3 pi over 2. And just the negative tells you the direction you're rotating, okay? This would be negative 4 pi over 2. Now, you're never going to see negative 4 pi over 2. You're going to see instead negative 2 pi over 2 because that reduces to negative 2 pi over 2. Okay, so you could rotate with a positive angle and a negative angle, okay? All right, and I want you to understand that, okay? All right, so let's go to the next one, okay? I'm gonna slide it up. Excuse me. Okay, and now we're gonna count by pi over 4s. And I'm hoping that this starts to make more sense, okay? So I know this is 0 and this is pi, right? And I'm going to take pi and I'm going to divide it into 4 equal pieces because that's what this dividing by 4 is, right? So what would that put me at? Okay, if from here to here is pi, I'm going to divide this angle into 4 pieces. So that would mean I'd have one piece right here, one piece right here, one piece right here, and one piece right here, okay? All right, so now that divided the angle pi into 4 pieces, okay? So if I divide into 4 pieces, this first piece would be pi over, this first angle would be pi over 4. Now, this next one would be 2 pi over 4. But nobody's ever going to call this angle 2 pi over 4 because 2 pi over 4 reduces to pi over 2. They're going to call it pi over 2. This next one would be 3 pi over 4. Okay, and then this angle right here would be 4 pi over 4. Now, nobody's ever going to call this angle 4 pi over 4 because they're going to call it pi because 4 pi over 4 reduces to pi, okay? Now, this is still angle, this right here is angle pi also, right? The angle size is pi. So what we're going to do is we're going to still continue to break this up into 4 pieces, right? Okay, so we're going to come down here. And then this would be 1 more pi over 4, which would be 5 pi over 4. And then we're going to come to right here, and this would be 6 pi over 4. But no one will ever call this 6 pi over 4. They're going to call it 3 pi over 2, okay? And then the next one would be 7 pi over 4. Okay, and everybody's going to call that one 7 pi over 4, okay, because you can't reduce it. And then this next one would be 8 pi over 4. However, no one is ever going to call that one 8 pi over 4. They're going to call it 2 pi instead. Okay? All right. Now, what if we keep going, okay? So this is 8 pi over 4. If we keep rotating around, right, we've gone 8 pi over 4, then this would also be 9 pi over 4. And then this would be 10 pi over 4, and 11 pi over 4, and 12 pi over 4, and 13 pi over 4, and 14 pi over 4, okay? And this would be 15 pi over 4, and then 16 pi over 4, right? And so we could keep going around and around and around, okay? Now, that's rotating this way, right? That's what we did, okay? And that's with a positive angle. Could you rotate it with a negative angle? And you could. If we rotate this way and we start right here, then this 7 pi over 4 would actually become negative pi over 4. And keep going this way, this would be negative 2 pi over 4. Now, nobody's, again, this one, nobody's ever going to call that one negative 2 pi over 4. They're going to call it negative pi over 2. Okay, and we keep going, and this would be, this angle right here would also be negative 3 pi over 4. Keep going, this would be negative 4 pi over 4, okay? And you get the idea there that we could just count by pi over 4. So we got to be able to count by pi over 2s. We got to count by pi's, pi over 2s, pi over 4s. And then the next one I'm going to do is pi over 6, and then we'll do pi over 3, okay? All right, so let's do this next one. And this next one we're going to count. There's a reason why we're doing these denominators, these specific ones, okay? They're actually going to give us special right triangles. And you'll understand this as we go along, okay? All right. So this time we're going to count, we're going to be counting by pi over 6, okay? So I know that this angle right here is 0, and I know this angle, if I rotate to here, that's pi. So this is taking pi and dividing it into 6 equal pieces, okay? So if we go from here to here, this angle right here, and we break it into 6 equal pieces, right? We're gonna have a piece that's right about here, a piece that's right about here, a piece that's right here, a piece that's right here. And then this is like fractions back in elementary school, okay? When you're doing the pizzas, okay? All right, so now we know that from here to here, we've broken into 1, 2, 3, 4, 5, 6, 6 equal angles, right? Each one of these angles is pi over 6, okay? Because we've taken pi and breaking it into 6 equal angles, okay? So that means this right here is pi over 6, okay? Then this would be 2 pi over 6. Now, nobody's ever going to call this one 2 pi over 6 because 2 pi over 6 reduces to pi over 3. Okay, so they're going to call this one pi over 3. Okay, then this angle right here, if we're counting by pi over 6, is this one would be 3 pi over 6. But nobody's going to call this one 3 pi over 6. They're going to call it pi over 2. Okay, and then this one right here would be 4 pi over 6. But no one will ever call this one 4 pi over 6. They're going to call it 2 pi over 3. This one right here, 5 pi over 6. And everybody will call it 5 pi over 6. Okay? And then this one right here would be 6 pi over 6. Nobody's going to call that angle 6 pi over 6, though. They're going to call it pi. Okay, so some of these reduce it, right? And you're not going to be here, but it helps us to, the unreduced form helps us to be able to count and locate where the angle is, okay? So it's really important that you realize that this is angle pi, or 6 pi over 6, or 7 pi over 7, or 8 pi over 8, or 9 pi over 9. These always have to match up, right, for it to be pi, okay? All right. Okay, so we can keep dividing this one, right? So if we divided this top half into 6 equal pieces, we're going to divide this bottom half into 6 equal pieces. So it's going to, so we can keep going around, okay? So then we'll have one here, one right about there, and one right about there, okay? So then if we keep rotating in this direction, this angle would be 7 pi over 6. This angle right here would be 8 pi over 6, okay? But nobody's ever going to call this one 8 pi over 6. They're going to call it 4 pi over 3, okay? And then this angle right here is, and I should have drawn this one in too. This one would be 9 pi over 6, but nobody's ever going to call this one 9 pi over 6 because they're both divisible by 3. So they're going to call this one 3 pi over 2, okay? And then this one would be 10 pi over 6. And no one's going to call this one 10 pi over 6 because they're both divisible by 2. So this is going to be 5 pi over 3, okay? And then this one right here would be 11 pi over 6. And everybody will call that one 11 pi over 6, okay? And then back over here, this would be 12 pi over 6. Which nobody's going to call that one 12 pi over 6. They're going to call it 2 pi because they're both divisible by 6, okay? All right. Hopefully this is starting to make more sense to you, because I know this is really difficult with it without seeing me and me being able to show you like the rotations of this, okay? So we took this 0 to pi, we broke it into 6 equal angles, okay? And so, okay, we rotated this way, right? That's the way we were rotating. Well, what if we rotated in the negative direction, okay? So hopefully you're catching up on this, okay? And instead of this being 11 pi over 6, we're going to rotate 1 pi over 6 in the negative direction. So this angle becomes negative pi over 6. And then this one would be negative 2 pi over 6. But nobody's ever going to call this angle negative 2 pi over 6 because they're going to call it negative pi over 3. And then this would be negative 3 pi over 6. But nobody's going to call this one negative 3 pi over 6. They're going to call it negative pi over 2. Then this one would be negative 4 pi over 6. But nobody's ever going to call this one negative 4 pi over 6. They're going to call it negative 2 pi over 3. And then this one would be negative 5 pi over 6. And this would be negative 6 pi over 6. And we could keep going around and around and around, right? Okay, with positive angles and negative angles, okay? All right, I know that's a lot of writing, okay? Let's turn the page and let's go to the next one, okay? Okay, so now this one, what I want to do is I want to count by pi over 3, okay? So we're going to be counting by pi over 3, okay? So from here to here is a rotation of pi, all right? So from here to here, rotation of pi. But I want to break this angle of pi into 3 equal pieces, okay? So I'm not going to hit this middle one this time, okay? So that's why I saved this one for last, all right? So we're going to break from this angle to here into 3 equal pieces. So one of the pieces would be way up here like this, and another one would be kind of more like this, okay? And these angles should be kind of about the same, okay? So this is angle 0 pi, okay, or 0 pi over 3. This would be angle pi over 3. This would be 2 pi over 3. Now this one's going to be from right here would be 3 pi over 3, but nobody's going to call that one 3 pi over 3, okay? So the denominator tells you how many pieces you break into from 0 to pi, how many equal angles you need to break it into, okay? The denominator will always do that for you, okay? All right, so now this is also an angle of pi right here, okay? It's just underneath, right? And since we broke this top half into 3 equal pieces, we want to break this bottom half into 3 equal pieces. So it's going to be, right about in here. And this is just ballparking, okay? Even when you draw these and I ask you to draw these, it's going to be, it's important that you get them in the right quadrant. And the more we get into this, the more you're going to understand like why I'm having you do this, okay? Right now it's like, why is he having me do this? I get it, okay? All right, so we're going to rotate 1 more pi over 3, which would put you at 4 pi over 3. Keep rotating, and this would be 5 pi over 3. And I don't know if you realize this, none of these reduce except for right here at 3 pi over 3. Okay, so this is 5 pi over 3. Then keep going to right here, and this would be 6 pi over 3. But once again, nobody's going to call this one 6 pi over 3. Why? Because that reduces to 2 pi. They're going to call it 2 pi. Okay? Then we keep rotating this way, and this would be 7 pi over 3. So you could keep rotating more than one rotation around, right? We could keep going around and around. Then this would be 8 pi over 3, 9 pi over 3, 10 pi over 3, 11 pi over 3, 12 pi over 3, and you could just keep going around and around and around, okay? All right? Okay. What if we rotate with a negative angle, right? So we rotate this direction, right? Okay, so if we rotate this direction, this would be negative pi over 3. Then this one becomes negative 2 pi over 3. And then this one would be negative 3 pi over 3. And negative 4 pi over 3. And negative 5 pi over 3. And negative 6 pi over 3. And we could keep going with that, okay? So hopefully you're starting to pick up on this, like, okay, I see, all right, how you're doing this, okay? All right, I wish I could see your faces, all right? All right, so this next one, okay, is not one you're gonna see probably really ever, okay? But to get the idea of this, all right, I wanna count by pi over 12, okay? Okay, so right here, this angle right here is gonna be 0 pi over 12. I know I've been writing just 0, okay? You could write this as 0 too, okay? All right, so this is gonna be important, all right? So if I wanna locate, okay, where the heck is something like 11 pi over 12, okay? Well, I know this is pi, and since I'm counting by 12s, I know this would have to be 12 pi over 12. Because what's 12 pi over 12? It's pi, right? Okay, if this is 12 pi over 12, okay, then straight up here would have to be half that, right? So this would have to be 6 pi over 12, okay? And if that's 6 pi over 12 and this is 12 pi over 12, then this right here would have to be half that, which would be 18 pi over 12. And then this would have to be 24 pi over 12. 24 pi over 12. Because what's 24 pi over 12? It's 2 pi, okay? All right, so that's just one more that I wanted to look at. Let me just check my previous notes. Is there anything else I wanted to add? No. Okay. All right, so now let's go back to our notes page, okay? And what I'm going to have you do, it will make more sense when we draw these angles in, okay? All right, so let's go back to our notes. All right, so for example 1, okay, what I want us to be able to do, this is a really important skill. We are actually building piece by piece each day until we get to where we need to be, all right? And I've done this in the past with you guys, and you guys have been very successful with when I just build a little piece at a time instead of just giving you everything at once, okay? So this is one little piece, okay? I wanna locate, and I wanna draw this angle in standard position. Now remember, standard position is we start on the positive x-axis and the vertex of the angle is at the origin, right? And so I wanna draw, what is this angle 13 pi over 12, okay? And what we just did is gonna help us determine where this is gonna land, okay? It's really important that you understand which quadrant it lands in, all right? So we're gonna draw in our X and Y axis. Okay, so I know I'm gonna start right here on the positive X axis, all right? That's my initial side. Vertex is at the origin right here, okay? And I'm looking at my denominator and it's 12, okay? So I know that right here, this is 0 pi over 12, or angle 0. Okay, right here on the positive x-axis, I haven't rotated anything, so it's 0. I know if I rotate to the negative x-axis, right, that is going to be pi, okay? So now, I don't want to write it as pi. I actually want to write it in a way that helps me, okay? So because my denominator is 12, well, how can I write pi with a denominator 12? Well, it would be 12 pi over 12. So right here is 12 pi over 12. Okay, because what's 12 pi over 12? It's pi, okay? Now, if I go from here to here is 12 pi over 12, then this would be half of that, right? And so that would be, this angle right here would be 6 pi over 12. And this is the one we just did, okay? All right, so that's, to rotate to here would be 6 pi over 12. To rotate to here would be 12 pi over 12. Okay, so every quarter turn is 6 pi over 12, right? So this would be right here, this would be another, from here, this would be another 6 pi over 12, which would put me at 18 pi over 12. Okay, so where is 13 pi over 12? And this is going to be important, okay? So right here is 12 pi over 12. I want to rotate 13 pi over 12. Well, right here is 18 pi over 12. Right here is 12 pi over 12. 13 pi over 12 has to be down here in this first quadrant, or in this quadrant down here, this lower left quadrant, right? Quadrant numbers, this is quadrant 1, quadrant 2, and quadrant 3, and quadrant 4, okay? All right, so right here, we're gonna draw this angle in. It doesn't really matter where you draw it as long as it's in this quadrant, okay? Okay, and so what we have here is this angle. We start right here. Okay, I should actually draw this side. Okay, and if we rotate from here to here, that angle that I rotate is 13 pi over 12, and that's my angle theta, okay? All right, so sometimes I think at the very beginning, it's helpful to label these, okay? So the denominator is gonna tell us how to break the angle pi, how many angles, or how to break the angle pi into how many pieces that we need, how many equal angles, okay? So right here, I want to do this one, okay? So 7 pi over 9, okay? So I'm going to draw my x-axis. All right. And then right here, this angle right here is, because I'm in ninths, right? This angle is going to be 0 pi over 9. This angle, if I rotate to here, is pi, but since I'm in ninths, this angle is going to be written as 9 pi over 9. Because 9 pi over 9 is pi, right? Okay, so what would this be right here, right? What would this one be right here? This would be half of the 9, right? So 4.5, and I'm fine if you write that. 4.5 pi over 9, okay? And then if we keep going, okay, this one right here would be 13.5 pi over 9. And then back over here, this would be 18 pi over 9, which is 2 pi, right? Okay. So if you look at this, I want to draw an angle 7 pi over 9, okay? So right here's my angle 0. So I'm going to start right here. If I rotate to here, that'd be 9 pi over 9. If I rotate to right here is 4.5 pi over 9. So 7 pi over 9 has to be somewhere in here, right? And it's going to be drawn, I'm just going to draw it in the second quadrant. Okay, and that's what's important on these. That is what's important. You get it into the right quadrant, okay? It doesn't matter really the relative size of it. It's just, it's got to be land in the correct quadrant, okay? So right here, I've rotated from the positive x-axis, I've rotated an angle here into the second quadrant, and that angle is 7 pi over 9, okay? All right, so that's how you count, that's how you find the location of these angles that are in radians, okay? All right, so I'm gonna go to the next example. Okay, I'm gonna slide it up. Okay, so for this next one is a negative angle, okay? All right, so I'm gonna draw in my X and Y axis. Okay, so my denominator is 6, so I'm gonna call this one 0 pi over 6. And I know I'm rotating in a clockwise direction because the angle's negative. So I'm gonna go automatically, I'm gonna draw this one, okay? I'm gonna go all the way to here to pi, negative pi, right? And this would be negative 6 pi over 6, okay? All right. And so if from here to here is negative 6 pi over 6, then from here to here would have to be negative 3 pi over 6. Okay, so this would be negative 3 pi over 6. This would be negative 6 pi over 6. This up here would be negative 9 pi over 6. And then keep going. And then this one would be negative 12 pi over 6. Okay, so we want to rotate negative 7 pi over 6. Okay, so if I rotate to the negative x-axis, negative y-axis right here, that's only negative 3 pi over 6. Keep going to the negative x-axis, and that would be negative 6 pi over 6. I got to go a little bit more, right? I got to go 1 more pi over 6 in the negative direction, which would be up here, right? Okay, so this is negative 9 pi over 6. This is negative 6 pi over 6. Negative 7 pi over 6 has to land in here in the second quadrant then, right? Okay, so it's going to look something like this. Okay, and I've rotated with a negative direction, okay? And I'll put this one in, this side in here too. And so I've rotated, starting here, I've rotated in a negative direction, negative 7 pi over 6. So this angle of rotation right here, this would represent negative 7 pi over 6 as an angle of rotation, okay? All right, and that's how you count in radians, okay? All right, so this next example, 260 degrees, is in degrees. This one's, you guys are a little more comfortable with degrees right now, I know, okay? So let's go ahead and do this one, okay? It's kind of the same idea, okay? This is angle right here would be 0 degrees, okay? And this is a positive angle, so we're gonna know we're rotating counterclockwise. So we know that this is 180 degrees. Then this one would have to be half of the 180 degrees, which would be 90 degrees. Okay, and so this would have to be 200 and this is another, from here to here is another 90 degrees. So this would have to be 270 degrees for my rotation. And then to here, that'd be another 90, which would add to 90 to the 270, which would give you 360 degrees, okay? Now, I only want to rotate 260 degrees. So right here's my initial side, okay? And I'm going to rotate 260 degrees. So if I rotate to here, that's 90, that's 180, that's 270. Ooh, that's too much, right? So I got to back off a little bit. And so this angle is going to come down somewhere right in here in this third quadrant, okay? So I know the angle, the terminal side of this angle has to be in the third quadrant here. And so this angle from here to here represents an angle of 260 degrees in a positive direction, okay? All right, so that's how you rotate these, okay? And how you find the location of angles in degrees and in radians, okay? All right. Okay, so I'm going to go to the next example. Okay, I know I said I was going to go to the next example, but I meant I need to talk about this thing called reference angles first, okay? So what is a reference angle, okay? And what it is, it's an acute positive angle formed by the x-axis Okay, this is really important. It has to be the x-axis, not the y-axis, okay? And the terminal side. Okay, and angle theta is the angle we rotate, okay? And the reference angle is gonna be, we're gonna call the Greek letter alpha, okay? So theta is equal to the angle of rotation and our reference angle is going to be alpha. It looks like a little fish, okay? That's our reference angle. Okay, so we're gonna look at landing in different quadrants. Okay, so if my angle of rotation is this angle right here, that would be a positive angle, right? Theta. Or if I rotate with a negative angle, theta this way, right? The reference angle would be the same. The reference angle would be the same. Okay. So let's talk about what would this reference angle. Okay, so it's an acute angle. Now, what does acute mean? You may not remember that. Okay, acute angle is an angle between 0 and 90 degrees. Okay, or in radians, 0 to pi over 2 radians. Okay, so this is going to be a small angle. Okay, all right, so it's going to be less than 90 degrees. Okay, and it's formed by the x-axis and the terminal side. Okay, so right now it's got to be with the x-axis and the terminal side, and it has to be 90 degrees. So for the reference angle for this one, it has to be this. Okay, this is my angle alpha. Now it's not this one. That would be really, really wrong, and I want to point that out. Yes, that's an acute angle, but it's drawn to the y-axis. You will get your numbers wrong when we do these if you draw your alpha right here. Okay, don't draw it to the y-axis. It has to be drawn to the x-axis. Okay, why am I emphasizing that so much? I see this so much that people will draw your referencing right here, and that's totally, completely wrong. Okay, and you'll get your problems wrong. Okay, all right. So draw it right here. Okay, all right. So the next one. Okay, so what if we rotate with a positive angle to this terminal side right here? Okay, that's my angle theta. Or I rotate with a negative angle this way. Okay, that's also my angle of rotation theta. Okay, so it could be either one. Okay, where's my reference angle, this angle alpha? Okay, well, angle alpha is made between the x-axis and the terminal side. So the x-axis is right here. Okay, the angle formed by this x-axis and the terminal side, that would be this one right here. Okay, so this would be your angle alpha right there. Okay, let's go to the next one. Okay, all right, so this one we could rotate if it's in the third. So I'm doing the different, I don't know if you realize this, I'm doing the different quadrants for you. Okay, what if the angle of rotation lands in the first quadrant? What if it lands in the second quadrant? What if it lands in the third quadrant? And then finally, what if it lands in the fourth quadrant? Okay, where's your angle alpha? Okay, all right, so if we rotate to this terminal side right here, okay, this would be our angle of rotation theta. Or if we did a negative angle, this would be our angle of rotation theta. Okay, but our reference angle would be made between this and the x-axis, right? So it can't be this one. Now, why can't it be this one right here, this angle? Because that's an obtuse angle. Okay, that's an angle that's bigger than 90. So it's made between the x-axis and the terminal side. It has to be this angle right here. That's going to be our alpha. All right. Okay, so the fourth quadrant, what if it lands in the fourth quadrant? Okay, so if we rotate with a positive angle into the fourth quadrant, that would look like this. That would be our theta. If we did a negative angle, we'd be rotating this direction, and that would be our theta. Okay, our alpha, our reference angle, is made between this terminal side right here and the x-axis, so it would be this angle right here. Okay, it would not be this angle. It would not be this angle because that's being made between the y-axis and the terminal side. It has to be drawn between the x-axis and the terminal side. So this would be our angle alpha. Just like over here on this third quadrant, this would not be alpha. Do not draw your reference angle to the y-axis. Do not draw your reference angle to the y-axis. Do not, okay? So right here, okay, it's made between the terminal side and the x-axis, not the y-axis. Don't do it, okay? Big warning, all right? Can you tell I've seen this a lot where people draw it to the y-axis, all right? So don't do that because it gets you get the numbers wrong, okay? Okay, so now let's do some problems, okay? So let's go to example number 2. Okay, so for example 2, what I want you to be able to do is find the reference angle, okay? All right, so if you look at this, we have rotated angle negative 3 pi over 4, and we're in the third quadrant right here, right? okay? And I'm actually gonna use green for us to do this because I already have this as red and blue, okay? So this is my terminal side right here, okay? This is my angle of rotation, okay? I'm looking at my denominator and it's 4, right? So that makes this 0 pi over 4. And to right here, okay, this would be negative pi, or because I'm counting by fourths, this would be negative 4 pi over 4. Okay, so the reference angle, my alpha, is always going to be a positive angle. Okay, it's always going to be a positive angle, right? So it's made between the terminal side and the x-axis. It has to be acute, so it has to be under 90 degrees. So that would be this angle right here. This is my alpha, okay? Okay, so in radians, this is actually really easy to calculate, okay? If I'm at negative 3 pi over 4 and I've rotated from here to here, negative 3 pi over 4, how much more rotation would I need to get to this negative 4 pi over 4? Well, I would need to rotate another pi over 4, right? And that's my reference angle, okay? So for this problem, my reference angle, alpha, is pi over 4. Okay, that's my reference angle. Because I'm at negative 3 pi over 4, I need to rotate another pi over 4 to get to this x-axis, okay, to get to the negative 4 pi over 4. Okay, all right, so this one right here, okay, this next one is, all right, here's the terminal side. It's in the second quadrant. I have a negative angle rotation, okay. The reference angle is the angle made between the x-axis, okay, and the terminal side. So it's not this one because that's not acute. It would have to be this one right here. So this angle right here is my alpha, okay? And from this, I know that because I'm counting by nines and I have a negative rotation, I know this is 0 pi over 9. If I rotate to right here, this would be negative 9 pi over 9. Okay, and I need to go a little bit more to get to 11 pi over 9, right? Or negative 11 pi over 9. And how many more pi over 9s would I have to do to get to negative 11 pi over 9? Well, I'd have to go to negative 10 pi over 9 and negative 11, right? I'd have to go 2 pi over 9s. That's my reference angle, okay? So my alpha for this problem would be 2 pi over 9, okay? Because I'm at, right, if I go to here, I need to rotate a little bit more, right? I need to rotate to negative 11 pi over 4. So this reference angle right here is 2 pi over 9. Okay. All right, let's go to the next one. Okay, so I know, okay, that this angle of rotation is 23 pi over 18. Okay, and I rotate in the positive direction this time, okay? My terminal side is in this third quadrant. Here's my x-axis, so this right here would have to be my reference angle alpha, okay? So what's the size of that angle right there, okay? Well, because I'm counting by 18ths, right? This is 0 pi over 18, and this would be 18 pi over 18, okay? And so, well, how many more pi over 18s would I have to go? Well, if I rotate to just to here, right, I got to rotate a little bit more. Well, how much more do I need to rotate, right? So if here's 18 pi over 18, I have to rotate 5 more pi over 18s, right? To get to 23, I'd have to go 5 more, right? So my alpha in this case would be 5 pi over 18. And it's easy to see because of our denominators, okay? It's a little bit harder with our, when we do this in degrees, okay? So like the next one's a little bit harder, I think, okay? All right, so for this next one, we rotate with a positive angle 330 degrees, okay? Again, our reference angle is made between the x-axis and the terminal side, all right? And it has to be an acute angle. So it's not this angle, and it's not this angle. It's this angle right here. This angle right here, that forms the acute angle, x-axis, terminal side. That's our alpha, okay? All right, so I've rotated from here to here 330 degrees. If I rotate all the way to right here, okay, that'd be 360 degrees, right? So what is this gap right here? Well, if I'm at 330 on the terminal side and this is 360 degrees, this little difference between these two would be 30 degrees. So that's my alpha. My alpha would be 30 degrees because I would need to rotate another 30 degrees to get to here, right? So that's why my alpha is 30 degrees, okay? All right, and that's how you get your reference angles, okay? Okay, so for today's assignment, what I want you to do, I want you to do worksheet TF2, okay? And so I'm gonna put today's date on here, 4/15, and that's what I want you to work on today, okay? This is probably gonna be the longest lesson for all of this, okay? It just takes a little bit of time, okay? To figure this out, because we had to talk about standard position. How do you draw an angle in standard position? How do you find the reference angle? So those are really the two key things. Okay, so what do I want you to be able to understand after today's lesson? Okay, after you do the homework. Okay, I want you to be able to draw an angle. So know where that rotation lands. What quadrant is it? The upper right, the upper left, lower right. Okay, so you got to determine that. Okay, you got to get that down, and then you got to find this thing called a reference angle. Okay, and we're going to use these to find trig values. Okay, so like cosine of 150 degrees. We're going to do it in radians instead, but you're going to be able to do those without a calculator. And I need you to be able to do them without a calculator, okay? And I'll show you how to do that through all of this, okay? All of this builds to really, okay? It's TF5, okay? And on. And you notice I gave you a couple practice days here, right? This is just going to give you practice in figuring out these trig functions. This is really one of the crucial things in trigonometry is that you're able to do this part right here, okay? TF5 down, okay? This is all building up to TF5, 6, 7, and 8, okay? All right, so you guys have a great day, and I will, I was gonna say I'll see you tomorrow, but I guess I won't see you tomorrow, huh? Okay, all right, you guys take care. All right, bye.